Picture this, a research ship in the middle of a calm, black ocean. At dawn, a drill core rises from the deep. Scientists crowd around as the cylinder opens. Mud, sand, and then a thin band of strange gray grit packed with glassy beads and tiny, perfect spheres. Someone whispers, "That shouldn't be here. What if the strongest evidence of a forgotten civilization has been sitting under our feet and under the sea the whole time?" Today, we're going to follow the breadcrumbs of a society that could have lived 100,000 years ago. Where would they have built their cities? What fingerprints would they leave in stone and sand? And if they were real, how would we actually prove it? Stay to the end, because our final twist turns the mystery back on us. To play this all the way through, we need a time and some characters. The clock is set to about 100,000 years ago, in the late Pleistocene. Our own species, Homo sapiens, already existed by then. Neanderthals lived in Eurasia. Great ice sheets came and went. Sea levels rose and fell like a slow breath. But advanced doesn't have to mean skyscrapers and smartphones. It could mean anything from a bronze and iron level city network to full-on industrial power with electricity, trains, and large ships, all the way to a society so efficient and low carbon that it leaves almost no trash behind. Or, wild card, they go off-world and keep Earth tidy. For this thought experiment, think of advanced as large-scale building, complex tools, energy systems beyond muscle and fire, and some form of long-distance communication and trade. Here's the twist. Even if a civilization like that existed, most of its ruins would vanish. So our best bet isn't monuments, it's fingerprints. Let's define 3 possible versions of this ancient society, because each leaves different clues. Path 1. Low-carbon high-tech. They're brilliant with biology, ceramics, glass, and stone. They mass-produce, but without plastics or fossil fuels. They heal with bioengineering rather than metal scalpels. Their power comes from wind, water, sun, maybe geothermal. They craft long-lasting, beautiful materials, but don't burn oceans of oil. Path 2. Industrial fossil fuel. They discover coal and oil. They smelt metals, build electric grids, run factory lines, lay railroads, and throw up concrete cities. This path is loud, dirty, and leaves behind huge quarries, mines, and a storm of industrial byproducts. Path 3. Space-capable minimalists. They keep Earth tidy. Their factories are small and clean. Their archives live in durable ceramics or crystal. They build rockets or space elevators and stash some artifacts on the moon, where dust barely moves and there's no rain to erase them. We're going to test each path against the one judge that never retires: geology. Pick a favorite, but remember, Earth eats ruins for breakfast. So what survives? If you're building cities, you chase the same things we chase now: water, trade routes, and rich land. That means coasts and rivers. But there's a catch. Coastlines move. Over the last few 100,000 years, sea level has swung up and down by more than 100 meters. During warm times, seas push inland. During ice ages, they pull back and expose wide continental shelves. A huge number of prime coastal sites from the far past would be drowned today, lying under shallow seas along the edges of continents. So, if a civilization flourished around 100,000 years ago, many of its ports, shipyards, and coastal cities could now be on the continental shelf, under 20 to 120 meters of water. Rivers change course, too. Floodplains bury old towns in meters of mud. Deserts march and retreat. Jungle eats everything. We like to imagine towering ruins sticking out of the sand. Reality? Burial. It's the quiet, patient winner. So the best real estate for ancient cities now doubles as the hardest terrain to search: shallow seas. Let's do a cruel time lapse. Take a modern city, now press fast forward. In a century without maintenance, nature chews through the edges. Steel rusts, roofs collapse. In 1,000 years, most buildings are piles. In 10,000, the skyline becomes mounds stitched with roots. Rivers cut new channels and carry debris away. Wind abrades everything. Earthquakes, landslides, and floods tear at the foundations. Animals tunnel through. Plants pry apart stone and concrete. If the site isn't buried, it gets recycled by the planet. So what lasts? Stone, ceramics, glass shards. Some concretes can last a long time, especially ones rich in volcanic ash. But reinforced concrete is tricky. Once the steel inside rusts, it cracks and crumbles. Metals return to oxides. Plastics break into microplastics. Paper? Gone, unless it's sealed, dry, and oxygen-free. But there's one more survivor: sheer mass. Big mines, giant piles of tailings, artificial hills from landfills. These bulky features can leave long-lived scars. They might not look like ruins. They might look like weird geology. If an industrial civilization lived and died, we might find a thin, scattered layer in the ground filled with unnatural leftovers. A techno-fossil horizon. What's in that layer? Microscopic fly ash spheres from burning coal, tiny glassy marbles you can spot under a microscope, metals and alloys at unusual concentrations. Aluminum, for one, doesn't appear in bulk naturally as metal. Concrete fragments and crushed bricks turned into sediments. Persistent plastics broken into microplastics that crawl into soils, lakes, and seafloors. Strange shapes of carbon and unusual ratios of isotopes that scream industry, not volcano. It wouldn't look like a museum shelf. It would be a speckled band in lake beds, river deltas, peat bogs, and ocean muds. A band with tiny artificial bits made by high heat, high pressure, and big machines. Even a low-carbon, high-tech society might leave its own signature: fewer plastics, more glass and ceramic micros, abnormal phosphorus from fertilized soils, engineered clays, and weirdly regular soil horizons where people farmed the same land for centuries. And if they burned a lot of fossil fuel, the sky itself would hold a clue: a carbon fingerprint. Carbon comes in different flavors, light and heavy isotopes. Plants prefer lighter carbon. Fossil fuels are built from ancient plants, so when you burn them, the atmosphere and the oceans shift toward lighter carbon. If a past civilization went hard on coal and oil, you might see a sharp dip in the carbon isotope ratio in sediments worldwide, like a whisper that says, something was burning a lot of old sunlight. You might also see an abrupt warming pulse in the climate record, changing temperatures, changing rainfall, changing ocean chemistry, in ice cores, in cave stalagmites, in lake mud. These signals stack up. What if they split atoms? That's tougher. Many radioactive markers decay too fast over 100,000 years, but some unusual clusters of elements, or odd spikes in certain metals, could hint at nuclear industry or heavy mining. This is detective work at the scale of sand grains. But nature also plays tricks. Volcanoes and meteorites can fake some signals. So what